One of the things that we need to be able to do in logic is negate our statements, even our compound statements. So for example, if we have the statement P and Q, what we could do is simply put a negation sign in front of it in order to indicate that we are negating P and Q, which would look like this. The problem with it is that it's quite silly when we want to translate it into words. So for example, if P and Q is the statement, it is Wednesday and I am blue, then by putting the negation sign in front of the parentheses, we would phrase this as, it is not the case that it is Wednesday and I am blue. Now, the reason there's a problem with this is because people don't really talk this way. The same thing goes for or. You might say, it is wet or the cake is delicious, and you wouldn't want to negate that and say it is not the case that it is wet or the cake is delicious. We just don't talk that way. So along come DeMorgan's laws, and they're going to help us negate and or in a way that when we speak, they actually make sense. It's actually part of the way we would talk. So let's put them here. So we have two DeMorgan's laws. One is used to negate and one is used to negate or. In the first one, you'll see not P and Q becomes not P or not Q. And in the second one, not P or Q becomes not P and not Q. So a few important things to point out. First of all, the negation on the outside of the parentheses acts in many ways the same way that a negative sign outside of a parentheses might act. What that means is it really negates everything that's inside the parentheses. So you can see, for example, the not, the P becomes not P, the Q becomes not Q, and the and itself is also flipped and turns into an or. The same thing for the second one. The P is converted into a not P, the Q is converted into a not Q, and the or is converted into an and. And so all across the line, everything inside that parentheses gets flipped. That's what DeMorgan's laws do. The other thing to take notice of is that there isn't an equal sign in between the statements, there's an equivalent sign. Well, if you recall, what it means for two statements to be equivalent is that their truth tables are the same. They give the same truth values. So let's take a look. Let's quickly draw the two truth tables to show why DeMorgan's laws are true. So as we look at the left-hand side, we have not parentheses P and Q. You can see the truth table is already started for us. We have P, we have Q. As a reminder, the rule for and is they both have to be true. And so if we want to negate P and Q, we just end up with false, true, true, and true. For the right-hand side, not P or not Q, we already have P, Q, not Q in our chart. As a reminder, the rule for or is at least one of them must be true, which leaves us with false, true, true, true. And so what you can see is, in fact, these two truth tables are equivalent. Their final columns are exactly the same. And so therefore, the DeMorgan's law is true. I will leave you to prove the second DeMorgan's law to be true as well. So let's just go back to our original statement. It is Wednesday and I am blue. If I want to negate that, I'm going to use the first DeMorgan's law, not P or not Q. This would give us, it is not Wednesday or I am not blue. Notice, it is Wednesday turned into it is not Wednesday. I am blue turned into I am not blue. But most important, and this is the part people tend to forget, is that your and turned into an or. And that is the same statement as this, which is the negation of our original statement if P and Q.